Hello? Can you hear me?
Yes, sir.
Yeah, we can hear you.
All right. Like I say, by weekend, I'm gonna upload the final assignments, the project, and second test. I'm gonna put it about making it available on Monday. The Monday they have the test two, which will be our last test. Then I'll tell you the date for the final. All right, let's begin. Today, starting from here, finding the data values, giving specific probabilities. Please, can you mute yourself, please?
Yeah. Oh, Lord, have mercy.
Miss Paul, can you mute yourself?
Yeah, I came off the
Thank you. Now, finding the data values. For this, to do this, we're gonna use this formula. X, which is the data value, Z times standard deviation plus mean. Where this S is the data value you're looking for. Data is the standard deviation, and this is the mean. How do you apply this? Look at a good example. To qualify, make it bigger. To qualify for a police academy test, candidates or police academy candidates must score in the top 10% on the general ability test. The test has a mean of 200 and a standard deviation of 20. Find the lowest possible score to qualify, and assume that the tests, of course, are normally distributed. So to solve this, we're going to use this formula that I just mentioned, solution. Okay. Now, in this case, the mean is 200. 100. And standard deviation is 20. Yeah. Now, the first thing is to figure out what our Z is. Once we get our Z value, we can be able to calculate the lowest possible score to qualify. And to do that, to get that Z value, we need a chart. So I'm gonna insert a chart here. So it's gonna be right from here, then up, and then here. Okay, and I'm gonna move some of this down. Now, so it said you need to find lowest possible score to qualify. That means to qualify, you need to score in the top 10%. That means 90% and above is the top 10%. So let's see. We're gonna put here. I'm gonna make this chart here and put a center line, which is 0. Okay. 0 is center line. I'll move this up a little bit. Okay, I'll move this up a little bit. Okay, so now top 10%, like I said, that means top 10, that means 90% and above. This is the top 10% here.
How do you know it's right there?
It can be anywhere on this, on the tail. It can be here, here on the tail. It can be. You don't have to measure it. You know what I mean? You just so long as it's at the top 10%. You know that from here, you can see that from here down is 90%. The top 10 right there. You can put it here anywhere on the tail, on the right tail, because it's a top 10%. You start from 0 here. Let's say that this is we don't have 0 here. So maybe it's 0.5, 0.5, which is 100. So you start from here all the way to 90. The top 10 started from here, you know. And since you're using this table, oh, excuse me, let me welcome these two people and meet all. Then, so we can now share the part that we are talking about, that is the top 10%. Oh, excuse me. Share it. Okay, we have this. Okay. All right. Okay. This is right here. And 2 more, and we'll be done. Last but not the least. Okay, we close it. So this is top 10%. Top 10%. Top 10%. So now in this case, they gave you the probability as 10%, you know, top 10%. So we need to go backwards, you know. So it's top 10% start from here. This is the cutoff point right here. See? This line is the cutoff point. So you have to score here above to qualify. Now, let us find the Z for this top 10%. Z becomes, remember I told you when it's on the left, on the tail, the whole of this is 0.5. The whole of this is 0.5. So if you want to get only this part, you subtract from 0.5. So 0.5 minus 10%, which is 0.1. 2.1. When you change 10% to 100, so to decimal, it's going to be 0.1. And since this table here that we're using have 4 digits, because of that, even though it is 0.1, we make it 4 digits by adding 3 zeros. Now, hold on, let me delete some. That's what I want to delete from here that is blocking us. Because I think this is it. Let me close this. Now, so which is 0.4000. Now, this is what we're going to look on the table for 0.400. So if you don't see this, we look for a number that is closest to it. Now, let's see. Look at it. We go to the table 0.4000. We look for it. We could not find it, but we did find 0.3997. Next one after that is 0.4015. Now, if you ignore the decimal point, you can see that this is 3997. This one is 401. So this one is 15 points away from 4000. This one is 15, but this one is only 3 points away. Because if you add 3 to this, you give you 4.400. So this is the closest. So we follow it to the left. 1.2 and up 8. Like it was 1.28 for Z. 1.28. Now, with this, you are ready to answer the question. So once you get this. Now, the question was asking you, find the lowest possible score to qualify. So that we're going to use this formula here. I'm going to copy the formula. Copy the formula. The lowest possible score to qualify is given by, so the lowest possible score to qualify is given by, is given by this formula. See, x equals z times standard deviation plus mean. See, this is the x right here. It's right here. That's the lowest possible score to qualify. See? So that means x becomes our z. We got 1.28 for z. So it's going to be 1.28 times the standard deviation, which is right here, which is 20, plus the mean. The mean is 200. So we have, let me write it down so we can compute this using a calculator. 1.28 times 20 plus 200. So we have 1.28. Excuse me, one mistake. I'm going to put them in parentheses so it should follow other operation. 1.28 times standard deviation of 20. Close it. Plus mean of 200. 225, then 225.6. So this is the lowest possible cost to qualify. 225.6. Okay, 225.6. Any question on this? Any question to this?
Nope.
Now, we can answer the same question, the similar question like that. Let me move it down a little bit. So in this case, we have this question here. It says, for a medical study, a researcher wishes to select people in the middle 60% of the population based on blood pressure. So the middle 60%. If this means systolic blood pressure is 120 and the standard deviation is 8, find the upper and lower readings that will qualify people to participate in this study. So our solution is this. First of all, values. We have the mean, which is the mean is 120. So the mean is 120. Mean equals 120. And standard deviation is equals 8. So let us figure out what our z is. To find z, we need to make our chart. First of all, make our chart. Okay, we go this way. Okay. Okay. And then we put our x-axis. Then we put our center line, which is 0. 0. They said that he wanted the middle, the middle 60%. So we're gonna put the middle 60% there. We're gonna put the line that represents the middle 60%. This is okay. And for this side is the middle 60%. So the middle of this, the whole of this is represents 60%. So we're gonna have x1, excuse me, x1, okay, we're gonna have x2. So we're gonna have two x's for the middle 60%. Okay. And then s1 and s2. And because he's saying it's 60%, remember he's halfway. That means it's gonna be 30% here. 30%. 30%. This is left side and right side. And 30% here as well. See? So when I add 30 plus 30 give you 60. So that's what you're gonna shed for the middle 60%. You're gonna shed it. All right, let's shed it. Okay. All right. 30 and 30. The shedding is usually easier when you are doing it manually. But you get there. Okay. You're almost done. Probably 4 more. And we'll finish the shedding. Okay, 2. Okay. 3. Then 4. Okay. Now this is the middle 60%. So we need to get S1 and S2. That means we need to get Z1. Okay. And Z2. But the good thing is that once we get Z1, we have already get Z because this is symmetric. So like they give you 30% already at the probability already. And this one is not in, unlike this one, which is in the tail, where we need to subtract 0.5. This one is not in the tail. It's from 0 to x1 and 0 to s2. So that means just 0 0.5, 0.3, 0, 0, 0. Look for this in the table. If you don't see it, look for the value that is closest to this. How do I get 0.300? Because 30% is 0.3. And to make it 4 decimal places, we add 3 zeros. So we can now go to our table of normal distribution. 0.300, we don't have it here, but we have 0.2995, which is like 2995. If you ignore the decimal point, this is 2995. The next number to it is 3023, which is 23 points away. This one is only 5 points away. This one is about, let's see, 0.300 minus 300, let's say 2967. So if you ignore the decimal point and do 300, if you do 3000, ignoring the decimal point minus 2967, you get 33 points away. So the one on the left is 33 points away. So this one is 33 points away. This one is 23 points. But this one is only 5 points away from 3.3000. So that's the correct one. Gonna be following to the left. You find 0.84. So we have the Z1 as 0.84. 0.84. Now because Z1 is on the left side, it's gonna be negative 0.84. So, and a symmetry, I have that Z2 equals 0.84, because they're symmetrical. Now we are ready to find the upper and lower readings. Okay. So it says the question says find the upper and lower readings that would qualify people to participate in the study. So that means lower readings, Z1, X1, lower reading is X1, equals Z1 times standard deviation of delta, okay, plus mean, okay, which is our Z1 and X1. Z1, X1 is Z1. Okay, X1 is, we need Z1 to get X1. So our Z1 is negative 0.84, negative 0.84 times standard deviation of 8 plus the mean of 120. And that will give us, write it down so we can calculate it. Negative 0.84 times 8 plus 120. So have it in that form. Okay. Put it inside the calculator. You got negative 0.84 times standard deviation of 8 plus mean of 120. Give me 126.72 millimeter of mercury. 126.72 millimeter of mercury. So 126.72 millimeter of mercury. That's how a blood pressure measured. Okay. And then the upper reading, we repeat the same process. So I'm going to copy it, but we now make it, it's going to be 0. I mean, positive. It's going to be I have X2. This is going to be upper reading. Upper reading. X2. X2. X2 becomes Z2. Okay. Plus delta times standard deviation plus mean. Because S2 is on the right side. It's going to be positive here. See? And that will give us the reading. So let's look at it on the calculator. We have it here. And let's change this to negative. Okay. 113 point. 113 point. Actually, the first one we did is positive, right? This should be the first one, negative. Or by mistake. So this will be the first one, which is Z1. Because this is negative. So it's gonna be 113. Let me correct the mistake. Please correct this mistake. When we make it negative, it's gonna be 113.28. 113.28. Okay. So I'm gonna correct it from there. 113. 113.28. But this one, if you remove the minus sign, it's gonna give you 126.72. So the lower reading to qualify is 113.28 millimeter of mercury, and the upper reading to qualify is 124.72 millimeter of mercury to participate for this study. Any question on this? Any question? Hello, is there any question for me on this?
No, sir. No questions.
No.
All right.
Is there a way you're able to share this this Word document and Canvas?
I shared the one we have yesterday, didn't I?
This Word document that you're working on?
Oh, the Word document.
Yes.
I have it on in a file, Canvas.
Okay.
So are
It
you
has your work in it?
are you talking about the one I just solved?
Yeah.
Oh, okay. I'll have to save it then again, then upload it. But if
I don't know what other students prefer, but it would be helpful.
But if you have the video, is it not the same thing? What do you say? What do you see? If you have the video, it's not the same.
You can see your work in the recording, right?
Yeah. If you go
Okay.
to Canvas, if I didn't have any problems the recording saved properly, I usually post it for you in Canvas. Miss Bista, is it not better?
Yes, I know. Yeah.
Okay. So now let's look at the next one. We have the suppose SAT scores are normally distributed. I'm not sure this space will be enough for this one, so let me move it down to we'll have enough room here. So suppose SAT scores are normally distributed with a mean of 950 and a standard deviation of 200. Compute the 95th percentile score. Again, solution. Know what is percentile? If you're scoring the 95 percentile, that means you perform better than 95% of all the people that took the SAT exam. So that the 95th percentile score, it is scored such that 95% of the area of the is on the left. 90 percentile score is the score such that 95% of all the score, because remember this is a percentile. So whenever you give it, they say that your score for anything, credit score, exam score, fall in the 95th percentile, mean that you performed better. Even if it's 95 or 98 or 80, let's say 80, that means perform better than 80%, or your score is better than 80% of American, which means that you're gonna lie in the area such that 95% is the area. It is called 95% of the area lie to the left of the curve. Okay, left of the curve. So having said that, we can now start just like before. The mean score is 950, and the standard deviation of that score is 200. Mean score is 950. The standard deviation of that score is 200. So let us find our Z first of all. To find the Z, we need to draw the our bell curve. Starting from here, we'll go this way. Okay. All right. Okay. And then we put our x-axis. Okay. And the center line. Okay, that's from here. Okay, which is 0. 0. So 90 percentile score will be the score such that 95% lies to the left of. So let's assume that you're gonna be on this tail. So this side will be at top 5%. This way will be your 95%. Let's say this, the whole of this 95%. But the core that make that the 95th percentile score is like on this line. See, which is your x. X. Okay. So we are looking for this x so that 95% fall below it. So I'm gonna share this. Share this from here. Okay. Now I'm gonna share this. All right. Okay. Make it faster. Okay, we're gonna make it faster. And then this 2 more, and we're done with that. Okay. And that's good. Now, so this is the S is the cutoff point, whereby 95% of all the scores lie below that. So this is your cutoff point, which is oh, excuse me, mistake. It's a cutoff point, which is here. All right. See, I'm in tab. We have this here. Okay, I'm gonna put it right here. So 95%, that means 5% left. Or 0.05. No, 5% is, if you change it to decimal, you're gonna be 0.05. See? That is the cutoff here. So to find the Z, they give you the probability already 5%. Remember, I told you that when it's at a tail, you have to subtract 1.5 because the whole of this is 0.5, then the whole of that is 0.5, making it 1. So now if you're looking for only this point, you do 0.5 minus 0.0500. And that gives us 0.5 minus, let me see, 0.5 minus 0.0500, 0.45, which is 0.4500. So you're gonna have it at 0.4500, 0.4500. Now, from the table, we look for 0.4500. So we just look at it as if there's no decimal point. That means we're looking for 4500. If we don't see it, we can use the number that is closest to it, which is here 4500, 4500. We have 4591, 4495. We have two numbers, 4495. Excuse me, because this is 4500. If you 45, this one is 4515, so it is 15 points away. This one is 4505, it's only 5 points away. This is 4495. If you add 5 points, now it becomes 4500. So it's only 5 points. So two of them have 5 points away. There are two equal numbers there. When they occur in this way, that we have two numbers that are equally close. Choose the bigger of the two numbers, which is this one, 0.4505. Then follow it to the left, 1.6, okay, and up 1.65, so that our Z becomes 1.65. 1.65. So with this, we are ready to find the 95th percentile score, so that the 95th percentile score is found as, okay, use the same formula we'll be using all this while, which is X equals Z times standard deviation, and the mean X equals Z times standard deviation from mean. So we have means the 90th percentile score represented by X. You know, X equals, we have Z is 1.65 times standard deviation of 200 plus the mean of 950. So this would be the the qualifying score, or what you call the the 95th percentile score. This will be the 90th percentile score. Now, if you put this in the calculator, we have write it down. We got 1.65 times standard deviation of 200 plus mean of 950. So I'm gonna have this calculator. We have 1.65 times 200, which is standard deviation, plus the mean. Oh, now I gotta put this in parentheses so that if you calculate it properly, then plus the mean of 950. You have 2080. 2080 with the 95th percentile score. Is it 28 or 1280? I think it's 1280, I believe. Yeah, 1280. 1280. 1280. Qualifying score. The 90th percentile score. Hope it's clear, right? Hello, class. Any question for me?
No.
All right. So we bring up the last thing we're gonna do today, which is in the normal distribution section. Last topic we're gonna discuss. So next week, Monday, we begin confidence intervals. It's called the central limit theorem, just like we did before yesterday when we calculate binomial. Normal distribution or normal probabilities. We use this one, except that two things are added. The sample size is number one, and the sample mean is number two. So sample size, sample mean are added this time. That's what changes. And that's what this theory is talking about. It said the central limit theorem, according to this theory, said that if you have a population with mean, mu, and the standard deviation, delta, and you take a sufficiently large random sample from the population with replacement, then the distribution of sample means we approximately approach and normally distributed, so long as the sample size is large enough. Even if the distribution did not come from normal distribution, as it increases sample large enough with replacement, it starts taking a shape, bell shape or normal distribution. That's what this is talking about. So in other words, the distribution approximates normal distribution as the sample size becomes larger, assuming that all samples are identical in size and regardless on the population distribution shape. So in that case, we now introduce two things. The sample mean will become equal to the population mean. There's a way of showing this, but at this level, you don't need that. And then the standard deviation will also be equal to the standard error, which is standard deviation divided by root n, where n is the new addition, which is the sample size. So as the sample size increases, this will take place. Now let's see how we can apply this in solving probability problems, in normal distribution probability problems. So it says for problems that involve central limit theory, we can use this formula. Z equals X bar. Actually, this is sample mean. This should be X bar plus population mean divided by standard deviation over square root of n. Where Z is the standard score or the Z value. X bar is the sample mean. Mu is the population mean. Delta is the population standard deviation, and n is the sample size. So let's see how this works. It says here, Nelson, let me move this down. Okay, we can use, yeah, let's just use Nelson. Either or can work. It says Nelson reported that children between age 2 to 5 watch on average 25 hours of TV per week. Assume that the sample, assume that not the variable is normally distributed, and the standard deviation is 3 hours. If 20 students between the age 2 and 5 are randomly selected, find the probability that the mean number of hours they watch TV will be greater than 23 hours. So you say, but say assume that the variable is normally distributed. So we're gonna use this as a sample. As an example, solution. We have the mean, sample mean, which is the S bar, as so the AC Nielsen reported that the children between age 2 to 5 watch on average 25 hours of TV. So this will be the population mean. A population mean is of all the students that watch TV, how much they spend watching TV is 25 hours. Now, and the standard deviation, okay, is 3 hours. So I'm gonna have it here. Standard deviation is 3 hours. 3 hours. Okay. Now, it says here, find the probability that the mean. Sorry, it says if 20 children were selected, so n sample size is 20. See? So you see, we added 20, and then we said if 20 children between age 2 to 5 are randomly selected, find the probability that the mean of the number of hours, I mean sample mean. You cannot get S bar from this page, so let me get it from our workbook. So S bar, excuse me, my mistake. Before I go, I want to write this down. So S bar is if the 20, okay, find the probability that the mean number of hours they watch TV will be greater than 2. So S bar is 23.6. Let me write this down so I can, let me see, 23.6. S bar. So we have our S bar here as 23.6. Okay, I'm going to insert the equation right here. So our S bar, I'm going to get it from here. Say, click on this, it gives you options. Okay, S bar is 23.6. So we can now plug this into our problem. So that right here, see? Now with this, we are ready to transform using the formula, okay? The transforming formula right becomes, so we got to transform S bar to its Z. Transforming formula will be this one here, Z equals S bar minus mean divided by standard deviation. See? So it's gonna be this. S bar minus mean divided by standard deviation to transform the S bar. So let us do it. I'm gonna take you to the other workbook so we can put this in. S bar minus mean, okay, which means equals okay, S bar minus mean. And what is our S bar? We're gonna figure it out now. So I have everything written out on that other workbook. Can you see my screen?
Yes.
Yes, yes.
Write this down. What is it not showing me? Okay, you know what? Okay. All right, let's see. I go here and then I'll go back. Okay, and I'm gonna go to the other side so I can copy my work. Okay, good. So our mean population mean is 25 and standard deviation is 3. Okay. And then sample size is 20. X bar becomes 23.6. Oh, sorry, actually 26.3, not 26.3. Should be 26.3, not 23.6, 26.3. Okay. Oh, excuse me. 26.3. Okay, I'm going to fix this now. 26.3. All right. 26.3. Okay, 26.3. So I'm going to copy this. Paste it there. 26.3. Okay. Right. So now let us figure this out and then get our answer to this probability. So with now going back, we have this in this form. I think I'm gonna copy this other one so that it will save us time. So I'm gonna copy this and paste it there to save time. Okay. All right, let's see. Okay. Now, which is equals to put this, have x bar, which is 26.3, 26.3 minus mean of 25 divided by standard deviation of I'm going to put this together, right? Standard deviation of 3 divided by square root of n. I'm going to put this right here. The square root of n, which is n is 20. So you can put this in a calculator to get our answer, and then we can now find the required probability. Okay, n is 20. Okay, samples is okay, 20 children. So let us finish up. So this will give us here have this. So we're gonna give us in a calculator. We can get this as we have. Okay, clear this. So parentheses. We have 26.3 minus 25, parentheses close, divided by, parentheses open again. Okay, we have standard deviation of 3 divided by square root of n, which is 20. And close it. It was 1.937. So we round it to 2 decimal places, which is 1.94. 1.94. So I go back and put 1.94, 1.94, and then I can copy it and put it on our question. And then I'll calculate the probability. So I have this here, 1.94. So now it's no longer 26.3. It is now 1.94, and it is no longer S bar. It is now a Z. So the probability of getting that they watch TV, that the number of hours they watch TV will be greater than 26.3 hours, because the probability of Z greater than say Z greater than 1.94. Okay, which will be obtained by drawing this chart. Draw the chart from here. So it is basically the same thing we did yesterday. I said that this time we introduce the sample size and the sample mean. So and use this and the formula for doing the transformation from x value from x value to normal variable.
Excuse me, Dr. OG, before you draw the graph, can you show the calculations once again?
Once
The
again,
26.3 minus 25 over 3.
Yeah.
And a square root of 20,
Sure.
I guess.
Sure.
Please.
Let me go back again and clear. So usually, if you want to get the number exactly in one step from a calculator, then you have to be careful with the parentheses. Parentheses will make you to have the correct answer. If you don't put parentheses, the calculator will give you something different. So I'm gonna do this again, which is x bar is 26.3. You can see that I put parentheses at the beginning, minus sample population mean is 25. Then I close the parentheses. That becomes our numerator. Then divided by another parenthesis, which is
Right.
the standard deviation of 3 divided by square root of 20, which is the sample size. Then you close the parenthesis. So that'll give you 1.9379. Here, that will be 1.94. Does that help?
Yes, sir. Yes, yes.
Go back now. So the probability that they
Thank
watch,
you.
you're welcome. That they watch more than 26.3 hours of TV, it becomes the probability of the more than 1.94. You can now put your chart here, and let's see right here. Okay. Now put it at this point here. Okay. And then this becomes, we are putting it on the right side because it is a positive. If it is negative, it will be on this side. Okay. Okay, so it's gonna be here. And this will be, yep. And okay. So this becomes our 1.94. The line this line presents 1.94. I'm gonna put it there as soon as I finish sharing this. Okay, this will be our last sharing. So this is a 1.94 right here. Okay, I'm gonna make it under. Okay, 1.94 is right here. 1.24. That's this line right here. So the probability, so because it's at the tail, when it's at the tail, we're gonna do 0.5. Remember, you're using this method formula because you're using this table here. This one is not cumulative. If you're using the cumulative type, you're gonna do a different thing. As a matter of fact, the cumulative type will give you the area right away. But when it becomes something, if it is the different shape, then you have to do just if you follow the rule in that other table, you can get the answer, the same answer. But I recommend that you use this one for this class because the answer will still be the same anyway. Minus, now I look for 1.94 on the table. You go to the table and you see 1.9. See the Z right here, right? So 1.9 is right here. You go under 4. Okay, 1, 2, 3, 4. So you notice that I didn't count this one because this one is the zero part of it. So you're gonna be from here 1, 2, 3, 4, and you follow it up and see the 4 right there. Okay, 1.9 under 4 is 0.4738. Right, I'm gonna write this down. 0.4738. So I go there and put 0.4738. 0.4738. Okay. And when you subtract that, you're gonna get your answer. So I have 0.47. Make sure I wrote the correct number here. 0.4. Sorry, my mistake. It's on the table. It's on the table. 0.4738. Yep, 4738. So now when we subtract this from 0.5, 0.5 000 minus 0.4738. 0.0262. 0.0262. Okay. So that gives us the answer to 0.0262. So you can see that the shape of the graph tells you what to do. So you have 0.0262, or what you can call 2.62% chance that they watch TV. The number of hours they watch TV is greater than 26.3 hours. Any question on this? Any question?
No.
Okay, now I want to show you something because this is our last example. This concludes our normal distribution. I recommend that you try as many examples as possible, and I want to show you this, the different charts and what each chart is talking about. So each chart, the way you draw a chart based on the question, will tell you what to do. So let me show you this chart. Let me see. I'm gonna open it from here. Okay, what different charts that leads to this.
Okay, I do have one quick question. Where did the 0.500 come from?
Where I got the 0.50 from? Okay, remember when I was introducing when I introduced the normal distribution.
Okay.
You can see this. Can you see this?
Yes.
Yeah.
Yes, yeah.
Half of this is 0.5. The half of that is 0.5. So on this part, you are looking for only the shaded part. So you gotta subtract it from 0.5. See that?
Okay.
So that's
all right.
So that's why I wanted to show you this different charts. Your question will give you the kind of charts you would use. Once you draw the chart, you can then follow the steps. You know, I think I have this chart for you too in the canvas under the file section. We call it procedure table. Can you see the screen?
Yes, sir.
Can you see this chart that I have here? Different problem will lead you to different types of charts. You see, if your chart looks like this one, it says look up the z-value to get the area. But if it is in the tail, like the one we just did, it can be on the right tail. The one we did is on the right tail. Sometimes it can be on the left tail. The solution will be look up the z-value to get the area, subtract the area from 0.5.
Oh, okay.
That's what
all right.
Did. Now, if the question they ask you led you to draw this kind of chart, this one, then what you're gonna do is after drawing the chart, you're gonna look up the z-value to get the area, then subtract the smaller area from the larger area. Now, if your question leads you to this type of chart, after you draw your chart, it looks like this, then what you're gonna do after that will be look up the z-value to get the areas and the areas. So when they say area, they mean the probabilities that we find from the from this what is the table? I think I closed. Remember the table we just used? Those are the probabilities. They call it the area, but they are actually probabilities. I'm going to statistical table. Okay, to bring it up. So what we are talking about the area, they mean those things that you found in this table here. You can see the table. Yeah, those things you found in this table, that's what they call the area. They are probabilities. Okay. So now if your chart, now I open this one, it blocked the chat, but I'm gonna bring it back. So let me close this one, close this table. We are back. I'm gonna close this one so that we have a room for this our procedure. So now, if your chart leads you to this kind of, if your question leads you to this kind of chart, that means after you drawing the chart, you're gonna say look up the z-value to get the area, add 0.5. See, there's 0.5 here plus the part you see on the table, and the same thing with that, 0.5 plus the part you see on the table. Then this concludes our lectures today. And let me take your attendance, and I will see you on Monday.
Okay.
So let me call your names.
Attendance.
Walker, is Walker here?
Walker.
And Bista, I heard your voice. Bista, you here?
Yep, I'm right here.
Miagia. Is she here?
You say Moshe?
No, Miagia.
I'm here.
Miagia, okay, you're here. Okay, good. Moshe, you're here. Miss Moshe.
Yeah, I was here yesterday. I don't think you put me down for here.
Picture. I have your name here.
Huh?
Moshe, right?
Moshe, you hear me?
Yeah, I checked. I'm actually present.
Oh, okay. Yesterday.
Now, Miss Moshe, remember that email that I sent you? I replied to your email and I said send me so I can send, because we don't have time anymore. You know that. I'm talking about what I sent to you before. So,
all right, I'm gonna look at it because I know we don't got time, so that's why I'm trying to get it taken care of. But I didn't see it attached, so I'm gonna look at your email. So because I want to try to get it all done before Sunday.
So then, now for those of you who are concerned about grading, I'll do most of the gradings this weekend, and the rest of them by next week. I'll try to finish everything before the semester ends, so you can know your grades on time. Okay.
Dr. OG, what's
going
on with the project? You said something about project. You're gonna load that this weekend too, or next week?
Yeah, I'm gonna put it there. Project is just see. I'm gonna put the data set you will use, and then upload the project question so you can just use the data set to answer those questions. Okay.
Oh, okay.
I'm gonna put them on this weekend. Sherry, who's Sherry? Debbie is here, right? I saw Debbie somewhere before. Is she here, Debbie?
Yes, I'm here.
But Dolly is here, right? Dolly, I see your name.
Yes, I'm here.
Johnson is here. Johnson is here. Rita, I know Rita. I know Rita was here.
Here.
I have her voice.
But the
You had the last correct response.
Is here. Keshona is here. Who else? Taylor.
I'm here.
Yeah, you got your name now.
Dijon Dunson said he is here.
Yeah, so Johnson. I put it in already.
Okay, and Vanessa is here.
Vanessa is here too. Vanessa, let me check Vanessa. All right, I got Kent. Miss Kent, come Mr. Kent. Is it Kent, are you Mr. or Miss?
Miss.
Yeah, I saw your email. I'm gonna reply to that, okay?
Okay, thank you.
Yeah, probably by tomorrow you get my reply.
Okay.
All right. Then who else haven't called? I think I called everybody. So Jatira is not here. Okay. Well, enjoy your weekend and see you next week. I don't like going to the chat room. Oh, I have already answered a check to Miss Thompson, so and Taylor. All right, let me close the class. At this point, we can end the class, and if this is saved properly, I will email you a copy.